The purpose of this video is to attempt to introduce a model of the heavens according to the Zetetic flat earth model. The first point I would like to bring up is what you were seeing here right on your screen. This is called a sundog. It is not possible to view this sunlight pattern or moonlight pattern by way of the heliocentric model of the solar system, nor would it be by the old geocentric model of the solar system. The heliocentric model is the view where the sun is at the center of the solar system. The Earth is a globe spinning on its axis while orbiting around the sun once per year. On that model, the sun would be shining onto the surface of the Earth, and this light would be reflecting through the atmosphere to cause this light pattern. However, it is simply not possible, and it is only possible if, on the contrary, the sun was inside of a domed sky ceiling and was reflecting off the back of the ceiling. As you can see here on your screen, this is very easy to reproduce with a bowl and a lighter. You will get all the same specific sundog, sun halo, mechanics, and patterns, down to minute details. If we turn this around and put the lighter at a distance from the bowl and put the camera right at the surface of the bowl would represent the thickness of the atmosphere on a globe model, and the lighter would represent the sun far in the distance, you will see that we get quite the opposite sort of light pattern no matter how we orient the lighter. Yet on the other hand, as you just saw, it is extraordinarily easy and readily done where one can mimic the sundog or sun halo by placing the lighter on the inside. So therefore, we can develop specific mechanics for the nature of Earth, its orientation to the sky dome ceiling, and other details. We are told that these sundogs and sun halos and moondogs and moon halos are incredibly rare. Almost everywhere I looked on the internet, that was the prevailing opinion. It is the opinion of this documentary that they are not incredibly rare, but in fact, they are usually mistaken for sun glare off of cameras. Furthermore, people are typically not looking into the bright sun. And so therefore, the average person on Earth does not have much of an idea at all of the shape, structure, and motion of the sun due to the fact that it's too bright to look at. So a lot could be going on with the sun which people would not even be aware of. In working on this documentary, I inadvertently noticed in the footage of the sun I was looking at, I would continually see these halos and sundogs, and also the double sun, which many people are mistaking for a second sun, but is actually just a reflection of the sun off the dome ceiling that we call the sky. So I started to develop the opinion that these sun optics are quite common, just unknown to the average person of planet Earth. Briefly analyze and compare the lighter inside the bowl next to pictures of sundogs. One thing I routinely noted is a glare above the sunset as the sun was setting. But if you look at this image here on the screen, you can see you have the lower portion where the lighter is, and it makes a sort of stretched out bell-shaped curve, which is another shape I frequently saw with sunsets. And then above it is a lit up portion. You'll notice these pictures here of sunsets mimic this to some degree. I would like to make it clear that I do not want to use this as evidence for the sky dome. I believe it's too loose of a comparison. I believe the sundog on the inner side of the bowl is a far stronger comparison, especially since we can mimic the specific mechanics of the sundog with the inside of the bowl. Nevertheless, it is interesting to point out this comparison to the sunset, as you're seeing on your screen right now. Please note, again, that each of these sun balls, the sphere of the sun itself, are white in these pictures that you see. Also, the bell shape is a very common shape I would see in sunsets, and which would sometimes extend for quite a while as the sun carried along its path. In summary, I saw lots of unexpected shapes when I examined setting suns, such as the one in the bottom right corner, which is not even spherical nor bell-shaped. This is not a very good image, but you can see the sidebar that's continually present in the sundog. The orientation I'm using here is not the same as on the horizon of the Earth, but notice the concentration nevertheless seems to always be in the same location. And looking to the right of the sun and the sundog and the right of the lighter and the bowl, it appears to be the case that there's always the concentration right to the side of the lighter and sun in each. And as you probably noticed, there's often a concentration over in that sidebar area. It'll be thicker. Now the top glare there, circled in green, that should be ignored because that has to do with the flat base of the bowl. And I think also on the left there, that top of the ring, sort of at 11 o'clock, 10 o'clock. When we change the orientation of the bowl where I'm more straight on, that the sidebar forms the same on both sides. We'll see in a minute. The sun, the lighter, is off-center, but the sundogs are always perfectly centered. That implies humans are always viewing the sky dome and sundogs, or moondogs, or sun halos or moon halos from a centralized area. Here, this one forms the bar on the left there when I get towards the middle. I would like to point out the weaknesses of this experiment. Firstly, the lighter is too bright, and the bowl glare is too intense. That is an asymmetry between the sun reflecting off the sky dome and the lighter in the bowl. Nevertheless, we can still make out the same geometrical shapes. They just have more brightness at times with the lighter and bowl experiment. I took a purely random Google search without any attempt to carefully select pictures to get a desired result. And you will see that Google search on your screen here, and you will notice that these pictures in the sampling are not very far down in the search. Let's look at all of these 7 pictures. The first picture you will see here, it's not entirely clear if this is a sundog, because it does appear there's possible camera glare with some of the 4 circles encompassing the edge of that halo. However, if you look at a sundog next to this, it does appear to have a similar structure. I was not sure if this was actually a sundog or if it was camera glare. It did appear to have too many of the sundog structures, such as the circle with the bullseye in the middle of it, to be ignored. Now let's go to the next picture. This one, as you will see, has a clear ring around it, which would appear to be a sun halo. Also notice the structure of the sun having an inner ring around it. And you will notice on the bowl experiment below, where I held a lighter under a bowl, you'll also see a similar ring around the lighter flame, which looks surprisingly similar, the way the colors are laid out. Also, please note that these sunsets you are seeing, every single one of them except the top right and top left one are white. The other ones are yellow. You do not see a red sun ball in these pictures. That will become relevant later in this documentary when we discuss the academic position on what sunsets are and what causes their colorfulness. Also, look at this picture of a sun halo further up into the sky and compare it to the one on the left of the sunset. You will notice that there are concentric rings in both cases, which is common with sun halos and moon halos. So therefore, the first 2 pictures appear to both exhibit sundog or sun halo mechanics. However, the third picture, I was not so sure. I had some ideas of how it could possibly look like it's being reflected off a dome wall in its background, but I nevertheless do not want to include this one as exhibiting any sort of a sundog or sun halo due to the fact that the characteristics are simply a mismatch. So we are 1 for 2. Let's look at the next picture. This one clearly exhibits a concentric halo structure. So 3 of the first 4 exhibit these halos. Now let's go to the next picture. This is another one that I did not want to include in the sampling. However, it does appear to have a halo structure. It does look like possible camera reflection going on, and the halo structure was not similar enough to the sundog or moondog structure. So therefore, I do not consider it justifiable to include this in the sampling, despite the fact that it does have concentric halo structure. So 3 of the first 5 match and 2 do not. And nevertheless, also the last 2 do not match as well. This one does appear to have some sort of a halo structure around it, but I do not want to include it since it appears to me to be very dissimilar to the sun halo or sundog structure, as is the case with the last one. So 3 out of 7 fits, 43%. This is just one simple sampling. You are encouraged to do samplings on your own to try to develop a percentage of how many pictures of the sun exhibit this structure of being reflected off the dome of the sky ceiling. I believe you will find that many pictures do exhibit this structure, and they are not incredibly rare. Also, we'll find out later in this documentary that the halo structure and the moondog structure are they require very specific positionings of observer and sky dome ceiling, with the sun in between the two positioned exactly right for the sundog or sun halo to form, and they only do so for a very short window of time. This is exhibited also in the bowl experiment, as you see right here. We'll discuss in this documentary at various points how the sundog and sun halo, or moondog and moon halo, tell us about the specific mechanics and structure of the sky dome and the earth plane located on the inner edge of it. This will also be supported by other details when we discuss the structure of the coloring of the sky and a number of other points in this documentary. When I watched footage of sunsets and sun motions across the sky, I often would miss double sun detection because I was so used to, in my mind, believing that this was just camera reflection. In these pictures here, you see a specific different shape of sun, as if the one, which appears to be behind and to the left, is being blocked out by clouds in a way that the one, which appears to be in the front and to the right, is not. This would be an indication that what we're looking at here is the sun being reflected off the sky dome ceiling. To my knowledge, if this was camera glare is something that does not happen in the clouds. Camera glare is something that happens inside the camera, because of, just like when you see a street light and you see a glare, rays coming off the street light at night, the glare can vary depending on how moist or dry your eyes are, and the glare is happening at your eyes, just like the camera glare is happening at the camera, not in the clouds. It is incredibly important to notice here that the second sun, or that is sun reflection to the right there, is behind those tree branches. How could it possibly be the case that is sun glare when it exists behind the tree in the distance? It would appear that this is a strong empirical verification that that is not camera glare of some sort, but is in fact a real image being photographed far into the distance, and therefore the second sun, as we're about to demonstrate right now by replicating the existence of this second sun in the salad bowl. As you can see here in this picture, we have part of the halo formed inside the dome bowl in our crude experiment, but we have a reflection right near the lighter to the left of the actual flame. And it would appear to be the case that it's for reasons you're seeing here in the lighter in the bowl experiment, that the back of the sun is reflecting off the dome ceiling. You can also see this here in the sky. You see a reflection of the sun emerging from behind the cloud over to the right of the sun. Now it looks like it's passing behind a cloud where the sun image does not. They're not in sync with each other. The image behind the cloud vanishes first. See that smudge there? That's why people often will think that the second sun, which is the back of the sun reflecting off the sky dome, is just camera glare, because it sort of looks like it. So notice this is the first point where the second sun shows up, and we're going to zoom in here on it, and you'll notice it's not the same shape as the sun itself. It doesn't have the cloud going through it, which has a glare, which you would think possibly be reflected in the, if it was a reflection that we're seeing there coming to the right behind the second tree. It has a smooth curve on the left, but not so on the right, as if it's coming out from behind a cloud. So we put them next to each other, zoom in, and you can see the asymmetries between the two photos. Different shapes in multiple ways. And also the top half of the reflected image is not as intense as the lower, so let's say lower 2/3. It would be very difficult for me to assert that the image to the right is camera glare. Notice there's the smudge in the same spot there. We're going to see one of those with the moon in a second. Right when you have that same smudge to the right in a lot of pictures. Sometimes it looks like a second sun or second moon. There's the smudge right there. So you see here in this image, both lighters are fully lit. There's even some glare and so forth. Let's move them over next to each other and zoom them in. And you'll see they're very comparable. But notice here in these images, which have a similar orientation to each other, the image on the right seems to be 2/3 of a sphere, the left 2/3, and it looks like it's coming out from behind a cloud. It's supposed to be fully lit up, just like with the mirror. So it's hard to say this is a camera cause. Okay, let's look at this smudge. It's not even spherical. It's got rays pointing out of it. And very important, it blocks out its background behind it, opposite of the sun image that was behind the tree. Very important. Big cuts deep into it. Colors discontinuous. Look at these two images here. Same properties do not exist. We've got a clear spherical edge on the left side of the one on the right, most of the one on the left, and then the smudge, however, not comparable. But from a distance, not as easy to tell. You have to be very careful to make sure you're not misrepresenting. See here, look at the image now, the second sun on the top. It looks like it's going into the cloud. See that red line? I see this sun effect frequently, where there's a first region of brighter light around the sun, and it'll often have a very sharp yet jagged boundary, but not a fuzzed or smeared boundary so much. And that's what you see here. You see a red line. I've seen that in many pictures. And the second sun seems to be vanishing behind that, as if it's vanishing behind the cloud, and as that boundary is being created by a cloud. Very difficult to say this is camera caused. And look at the smudge there. That white is from the arrow that I had pointing to it. Yeah, there's very different images here. See, notice the bottom half of the second sphere is more illuminated than the top half, as if it's going behind the cloud. And yet the sun on the bottom, full illumination all across. It appears the best theory is this is a reflection off the sky dome. How do we avoid that with what we just saw? Passing into the clouds. Coming out from behind the cloud there. Look at these, compare these two images. It seems every time we look at these images, there's no continuity from start to finish. How do we say one is a glare of the other with no similarity? And with it looking just like a sunball, clear boundary. See, now look at this video. This is how a glare camera caused effect works. Watch these images. They perfectly mimic each other. They change shape the same way, and so forth. We're not going to talk about the moon much in this documentary, but I just want to show some footage here. It'll be a future edition of Zeteticism about the moon. Now look at this footage here. Without careful examination, that might look like reflection off the dome ceiling, right? Put them next to each other. Hard to tell exactly what's going on, but they're far apart also. When they're far apart, one is much smaller than the other. So man, this sure looks like a second moon, doesn't it? To my knowledge, we don't see the double sun or the double moon that far apart. Here you're seeing on the glass a reflection of the double image behind being much smaller. Not a similar situation as to examining the sky dome, which would be examined from inside the bowl. But look, right there. Sky is clear over the second moon, cloudy over the moon, yet the second moon still vanishes. That's camera glare. That's not a reflection off the sky dome. If it were, when the moon vanished, you'd still see the reflection going the other direction off the sky dome. There are three factors we need to consider when considering these reflections off the sky ceiling by the celestial objects. One is the circular structure or concentric circles themselves. Then there are also lines that can be, in predictable ways, connected to and transcribing through and about the circle, as we've already seen a bit, as you're seeing here on your screen. Also, the sky ceiling is structured in such a way that the sundog or moondog is a quick emanation which is not long lasting, due to the fact that it only exists in a small window of positioning with respect to observer, sun, and sky dome. I found that it was only the case that I could get an exact replica of the sky to occur if I would put the bowl opening level to one of my eyes and put my eye at basically the very center of the bowl opening, wherein I would orbit a lighter flame very close to my eye, almost burned myself a few times actually, making a ring approximately 15 to 25% on my estimation from the central point of the bowl opening to the edge. So in other words, only if the observation happened from around the center region of the bowl, where the sun was low, where the lighter is close to my eye, making a small ring, would we get exactly the same mechanics that are seen in the sky, where sun halos form to the same size, and where the double sun exhibits similar characteristics. I tried many other configurations, but it was only this single configuration and approximations of it which would give me what I estimate is a replica of what's happening in the sky. I say this because when we look into the sky, the only reflections of the sun off the sky ceiling are the double sun and the sundog, to my knowledge. But if one uses many other orientations, such as bringing one's eye lower than the level of the bowl, putting the lighter closer to the edge, and so forth, all of a sudden then many other reflections along the bowl ceiling would take place. We don't see these sorts of reflections in the sky, to my knowledge. That is why I'm saying that only when one's eye is level in the center, making a close ring, only 15 to 25% toward the edge, do we replicate the sky. In that case, the only reflection, to my knowledge, that we get is a reflection of the sundog and the double sun. Please note that for the formation of a sundog or a moondog, a sun halo or a moon halo, it is required that the sky dome ceiling is spherical. In the bowl experiment, we saw the sundog or the sun halo change its size as the lighter moved in various orientations to the inner wall of the bowl or dome. The footage you are seeing on your screen is taken from San Francisco, where a very astute filmmaker kept the camera in the same position for a month and photographed 21 sun halos, thus claiming they are anything but rare. What we'd like to see from this footage is that sun halos change their shape. This would be a strong indication that we can tell that the sun is changing its distance and proximity to the sky dome as it traverses through the sky. If the sun halo was caused by ice crystals in the atmosphere, or some other atmospheric effect such as the cloud, as is ubiquitously theorized worldwide, then it would have to be the case that something changed its orientation. It would have to be the case that the atmosphere changed its height. To my knowledge, atmosphere forms in the globe model rings around Earth, rings of density, and the flat model, clouds and so forth, follow roughly straight paths, is how this would look in the flat model. And there are not very significant elevation differences in these levels of air densities. Or it would have to be the case that the sun changed its distance from planet Earth. On the globe model, it might be claimed that the spin of the globe Earth accounts for a small change. On the flat model, it would be claimed that the sun traversing through the sky changed the orientation of the sun to the surface of Earth. On the globe model, the surface of Earth will have largely accounted for only a lateral change in orientation to the sun. Very little distance change accounted by the spin, since the sun is roughly parallel, so to speak, in the sky. The orbit of the Earth would be considered negligible, since it would be so minute in the amount of time that the sun crossed the sky. It would appear, possibly, that the model that makes more sense is to consider the sun traversing across the sky and changing orientation to the sky dome. On that model, the changing shape and the changing size of the sundog seems to be a good fit, whereas the globe model will likely be a more difficult fit to account for this change in the size of the sundog. This is the first part of our analysis of sundogs and the sky dome. This analysis will continue directly from this spot in Volume 3 of Zeteticism, which will be out in October of 2015. The analysis in Volume 3 will be far more extensive than this analysis of the sundog sky dome in Volume 2. This is merely, in this volume, an introduction to the concept of the sundog being a picture of the sky dome via a reflection off the sky dome of the back of the sun. The evidence in this volume, and much more so in Volume 3, will appear to give overwhelming empirical verification that what we see when we look up into the sky is a spherical dome ceiling.